All right, lights down, lights up, mic on, we're good. Wow, these rooms this year are so hard to see from. I really like seeing my people, but that's okay. Thanks, everybody. Hey, look at that. Look at that. He's even got dimmers. I can see you better now. Thank you. Hi, everybody. Thanks for coming out. I did not expect such a full room. This is really cool. What we're here to talk about today is some of the developer productivity and quality tools, things that you probably saw this morning in Brian Harry's keynote demo. And since I'm using the clicker thing, let me find it. There we go. And I'm going to take you through some of that stuff. I've been working with the teams that have been building this stuff for the last year or so, and we're really excited to get an opportunity to share it with you today. You got some early glimpses at it, but we're going to spend a lot of time in the product looking at the bits. And because it's kind of a big, dark room, I'm going to ask you, if you have questions, write them down in your little notepad and hold them, and I promise I'll leave some time at the end. We've got mics all over the place. And of course, when I'm done with the session, I will hang out over here or outside as long as there are people who want to ask me questions. So I'll just give you that commitment right now so we can get that out of the way. Okay, so just a quick bit about me. I work for the Visual Studio product team, but I live in Denver, Colorado. I'm one of those weird Microsoft guys who lives and works remotely, which people have claimed forever can't be done, but I've been doing it for 5 years now. I'm an agile zealot, I guess you would say. I've been known occasionally to wear the robe and sandals, which is kind of fun. And been involved in that community for probably longer than I've been at Microsoft. Nice thing about, of course, being remote employee is I have only a 15-foot commute, and my t-shirts and jeans and shorts thing works out really well. I like to play music. I like to do karate with my son. But what I really like doing and have since I was 9 years old is programming computers. And in particular, I really like tools that allow me to be more productive, more flexible, more agile, write better code, and make my customers happier. So, of course, I work in the perfect place to be into that kind of thing. But enough about that. Click. Excellent. So I'm going to spend here just a couple of minutes and kind of talk about some of the challenges we face building apps these days. And you'd think as we were getting newer platforms and languages and tool sets and all this, that this job would be getting easier and easier. But it doesn't seem to actually be that way. I go out and meet with a lot of enterprise customers all over the country, all over the world when I'm traveling to conferences like this. And it doesn't seem that it actually is getting better for anybody. If anything, it's getting harder. Does anybody think it's easier now than it was 5 years ago? Yeah, we've got a whole bunch of new challenges that we have to face. As people are going more to the cloud, as people are getting involved in services, we're seeing a lot of different kind of platforms that people are trying to support. Of course, you heard this morning they were talking about, bring your own device to work is becoming commonplace. So the way we have to build these things and the customers we have to target and the platforms we're targeting, there's a lot of challenges for us. But in fact, many of the challenges are ones that we've had for quite a while. The large code base problem seems to still just be pervasive. I am frequently meeting with customers who are telling me about code bases that they work in that were written, before they ever even came to work there, and they've been working there for 10 years. And they still have to maintain it, and they still have to work in it, they still have to fix bugs, they still have to do all that stuff. So we've got these large code bases, and we're frequently finding ourselves having to work in them. This legacy code problem is real. And in fact, Josh Weber and I have a talk that we'll be giving you tomorrow, and hopefully we'll see a bunch of you there, where we're going to talk specifically about the challenges around testing in a legacy code base. But just even navigating around in a code base where you are unfamiliar presents a lot of challenges, and understanding what's there and what's not. Of course, agile development has moved from niche to pretty mainstream these days. As I come to rooms like this and talk to people, I discover that, whereas I used to say, how many people do agile, and I'd get a few hands and I know all of them, now everybody's hand goes up, or most people. And this agile thing where we're now building ready-to-ship software more frequently with a constant attention to quality and shippability is also changing us, because now we're seeing a desire for very continuous delivery. And of course, continuous can be variable depending on your team and your business. In Visual Studio, we're really psyched that we're now shipping multiple times a year. We're shipping the cumulative updates. And here we are now announcing this morning Visual Studio 2013 for preview for you guys in a few weeks. And, it was only a year ago that we were here doing this before. So we're changing our models. And I know from talking to you guys that a lot of you are as well. And this is also one of the challenges we're facing, is how are we dealing now with code bases that are constantly being revved and deployed or perhaps even in production, and we're having to work in that model. This continuous delivery thing, especially in the web situation, right, is interesting because we're now finding ourselves where we have to diagnose and trace down bug fixes for systems that are running live in the cloud on services. And there's a whole bunch of tools that even extend far beyond what I'm talking about here today that cover that space. And you saw a lot of that in the keynote this morning as well, and we'll see more of it in coming sessions or even throughout the year. There's basically too much information that you need to have, too much information that you want to try to maintain, and you just can't keep it all straight. So we find ourselves then, right, working through these unfamiliar code, and how do we deal with this? Too much stuff, right? We just have way too much stuff. And then there's the context switching aspect, where we're working on a problem, or maybe we're working on the next feature that, clicking. We're working on a feature and the boss comes running into your office and says, hey, stop what you're doing. The service site is down and we've got customers getting turned away from the login screen or whatever it is. And you have to do an instant context switch. You have to put down what you're working on. You have to switch over to that live system, try to figure out what went wrong, maybe pull down the code. Maybe it's code you haven't ever worked on. You have to work your way through that problem, try to figure out what it is, get a fix deployed, and then context switch back to where you were. This is tough. Again, so now we're collecting up lots of information, we're assembling it in our minds, we're trying to establish some of that situational awareness, and then we have to switch, reestablish it, switch back, reestablish it. And this becomes a very difficult thing to do. Because it turns out, we have a very limited amount of storage in our brains. Right? We can maintain something in the neighborhood of 7 active working concepts at a time. And when you're sitting and working through a problem, you'll exceed that very quickly. So we have to figure out how to keep track of all this stuff. Situational awareness is the thing, the phrase I like to use when thinking about this. And it's commonly used in the high-profile situations like air traffic control or the military. Strangely enough, it also comes up in online gaming. Kind of surprised me. But apparently, where teams of people are doing MMOs or whatever, and they have to try to figure out how to do it. Apparently, one of the things they differentiate skilled players from not skilled players is situational awareness. So I found this definition of it. The perception of elements in the environment within a volume of space and time, the comprehension of their meaning, and the projection of their status in the near future. It's awfully wordy. This is better. Knowing what's going on so you can figure out what to do. Same thing, less words. So we need to have a way then, we would really like to have a mechanism that allows us to try to extract information quickly, have it available to us when we need it, in the context of where we're working and what we're doing, so that we can use that to make quick decisions. Because ultimately, situational awareness is about being able to make decisions. And so it's, the military and the air traffic control applications are clearly like that. And you can learn this, and people do learn this, and you get better at it, but as soon as you enter into an unfamiliar code base, even if you have the mental skills for it, you still have to start with basically a clean slate and try to build up from there. So I don't have very many more slides because I want to actually get into the product and show you a little bit of stuff here. So I'm going to have to make sure that I can get these tools here to work on the stage, and then we will be good to go. Excellent. Okay, so I'm going to be taking us through a number of different parts here, and then I'll bounce back and forth occasionally to slides just to talk about what it was that we saw. The first thing that I want to take us through, you guys really do have a front row seat, don't you? Is that... Don't even have to look up there. Okay, great. The first thing I want to show you is a thing that we actually started introducing during the updates, the cumulative updates for Visual Studio 2012. And it's a nice little feature that we call Code Map. And it's quite simple to use. I just want to show you. So here I am. I have this code base, and basically what this project does is it reaches out to the U.S. Geological Survey. There's a web service up there that returns to me earthquake data, and then I plot it up on a map. Okay? But if I'm sitting and working through the code, and you kind of have to ignore all these cool little indicators, I promise we will be coming back to those, and I want to look at this method, I can hit on my keyboard Control and then backtick. That's the keystroke we use, but there's also something in this context menu for it. This show on code map, you can see Control backtick. And what we're going to do is we're just going to basically take that method, fire up a map very quickly, pop it on there, and let us roll from here. Now, you might say, well, okay, that was not all that interesting. But it turns out the interesting bit is what I can then start to do with it. So because this is a map where we have the code and we have the system behind it all, we can start to ask it questions. So we can ask it to find all references. Let me just full screen this. There we go. Right, so what this has done for me is given me a visual representation of the references into that code from my system. Now, of course, we had this in the architectural modeling tools that we started shipping in 2010, but if you recall, you had to either generate the gigantic diagram for your entire solution, which really wasn't what I wanted to ask it about. I was here. I was at start timer. I wanted to know how this guy worked. Or I had to figure out how to drive the Architecture Explorer, which you may have seen me present way back then. And it's amazingly powerful, and we still have it here, but sometimes I just want this thing. So you click on this thing and tick, and there it is in there. And now I can use this in a way, I can use it like a navigator, like a browser for my code. And I can continue to ask further questions, right? Who is it who calls into that guy? Nobody. Right? This one's a test, so I can figure out what that guy is and say, maybe I don't want to see him anymore because that's a test. I don't care about tests. Go away. So this is nice. Now, a couple of other things that we've added to this that are convenient, which is, you're sitting here browsing through your code. So typically when I run with this, I'll run it in this kind of a model. And I'll be using it to navigate. So if I double-click on one of these, it does exactly what you expect and lets me go and look at the code. And I'm working my way around trying to understand what I'm seeing. And I say, oh, okay, yeah, I'm interested in this. So I'm going to flag this one for follow-up and maybe attach a note. Come look at this later. Right? So now I can just basically stash this over here and continue what I'm doing. Okay, so here's the constructor. All right, and it's going to go down over here to start timer. Okay, and start timer is going to go over here to refresh data. That's interesting. Let's put refresh data on there. Control tick. Let's try a different layout. Here we go. All right, so now I'm over here looking at refresh data. All right, and so I can start to build up this visual model. And of course, it's a file, so I can save it. I can attach it to a work item. I can mail it to somebody, whatever I want. I can even export pictures of it and all that other good stuff. So I've now been able to annotate this while I'm doing my navigation, while I'm doing my exploration. So now if one of those context switch occurs, I have almost some notes. But they're visual notes, and they're notes that are directly coupled to my code. I can use them in the code. Right? So who else calls this guy? We get some more stuff added to our method. And of course, it can get, pretty full up. There can be a lot of stuff here, so we can maybe, like I showed you before when I took those tests and made them go away, well, let's take these tests instead, and we could, wrap them into a container. All right, so we could wrap them up in a group maybe or something like that. There we go. Call that tests. Okay? And then maybe I'll say I don't want to look at those anymore. All right, so I'm able to build this model very quickly, understand what I'm doing, see the parts of my code, and navigate through. So let me switch back over here real quick. So remember, we shipped that in the first update to Visual Studio 2012. Come on. There we go. And it was building on the technology that we shipped in the previous version, trying to make this simpler, trying to make this easier, more powerful, faster for you to use. So you can very quickly use this to get through your code, adding things people were looking for, like flag for follow-up, put their own icons on it, color it, all those things that you just need to be able to do. It's a simple drawing surface, but it's a drawing surface that is tightly coupled to the structure of your code and therefore gets all the benefits of that. You can ask queries of it, like you saw me when I pulled references or calls methods and those kinds of things. So build this thing out. Now, in the second update, we went and added some more. And what we did is we enabled this code map experience to now integrate in with the debugger. So I want to show you how this works, because this, I think, is where it really starts to shine. I'm going to close that map because we'll just start with a fresh one here. And let's set ourselves a breakpoint right there. Get the right project to start. Here we go. Okay, so of course everybody knows the debugger, right? It's the one thing that every developer just knows inherently. It seems like you spend all your time there, doesn't it, right? Setting breakpoints, looking at watch variables, doing all that stuff. And you know, the call stack window, let me get out of full screen so we can be in normal mode here. The call stack window is our friend when we are debugging. Right? It helps us keep track of where we've been and where we're going. And so here's the problem that a lot of developers face, that I'm sure you've run into this. You're looking at the call stack window, you realize, okay, that's the one I want to go look at. And so you stop, and it's gone. All right, let's try that again. So we're back here again. Well, what if instead I could just say, take the call stack and put it on a code map? So now we've gone directly into the debugger's call stack experience, pulled that out, and put it into the code map. And as I continue to interact with the debugger, I'll just do an F11 here to step in, we keep up with you. We continue to follow along. Go ahead into there. So what that is telling me is that I stepped over some magic hidden async code. That's fine. Not a problem. Okay, so you notice that the map it's building for me now, it put the red dots where the breakpoints were. It's keeping track of with the same iconography that you're already familiar with of where the current call stack frame is. And as you would expect, I can also use it like I was using the call stack. Just like when I'm navigating code, I can use, I've got to bounce through a bunch of property getters here. Here we go. Right, so you can see we're down in this property. Let's keep trucking along. Whole bunch of property getters here. All right, so it's building up this map for me as I go, but I can always tell where I am and which parts of it are in the actual code call map by the coloring of the icons. We've already taken care of that for you. So let me get us back to a clean state where I hadn't stepped through half the world. And I want to show you something else that's fun. Okay, so if I again bring up the call stack here, and let's switch this to top to bottom, okay? Kind of what we're used to seeing. Well, of course, if I'm in the call stack, I can double-click down here in the call stack itself and navigate through the call stack, which moves kind of this instruction pointer thing along with me. Well, I can also do that right here in the map. So now I can use this as basically a place in place of the call stack, but it's maintaining the sequences as well. This is really nice if you have code that has looping structures, perhaps looping structures that contain branching logic, where certain passes through the loop you'll leave and go out and come back. You will see those flows in the code map. And again, I might be sitting here debugging, trying to figure out what the problem is, and I can again do all of these things I was able to do before. Annotate the map, do everything I want to do, query the map, just like I did before. And now you can see we're getting some differentiation between the various node types here. So the green ones are ones that I basically queried out of the solution. The orange ones are active call stack sequences. And as I continue to step through, eventually some of these will go gray because they're kind of no longer relevant to the current call sequence. And now I'm back to this call chain. So now we're able to leverage this power of this visualization surface that we put together in the product a while ago in a much more dynamic and interactive way. And integrating it in with the debugger lets us get all that power as well. So hopefully that's interesting to you guys, because we are certainly finding it very useful. Let me drop back over here to slides now. Oop, no, not that way. This way. Okay. So again, when you exit the debugger, the call stack's gone, but the code map isn't. So all those notes, annotations I took, all those flaggings, all those things I put on there, the extra bits of information that I pulled out through querying, as I was stepping through, I was able to see the control flow. Because that's how control flow works in our minds, right? We actually do tend to visualize it like that. And so that allows us to have that same visual flow in that diagram. And when we stop debugging, we still have it. So we have that to remind us of where we were. Because we may have been stepping through code for 5 minutes and trying to build out this sequence, hiding the nodes we didn't want to see, keeping the ones we did, adding notes and annotations, and when we're done, we have that reference. This was the result of our discovery. Now you can use that, because it's bound into your code, to navigate through, to go back to those places, to make the edits you might want to make, and you can continue to use it even outside of the debugging session, because again, it's just a code map, just like the one I showed you in the first demo. So that was something we delivered then in the second update to Visual Studio 2012. Now as we're getting into the things that you saw this morning, I want to start to, this is where I want to spend kind of the meat of this session, because I want to really get in and spend some time here talking about what we can really do to bring even richer information to the developer experience in the IDE. So what we're going to be looking at is a thing that in the preview builds is called the code information indicators. Let's jump back over. Get out of debugging here and start taking a look at what we have here. So what you're seeing here on the screen, if we just go to that, where's that start timer guy? There we go. So if you'll notice here, right above the start timer method is this little gray line. Now, we call this the indicator panel, and it's not actually part of the editor. It looks like it is, but we're overlaying that on top with extra information that we're able to pull out of all kinds of different systems. And then we plug into that panel these indicators. Now, in this method, you're seeing 4 different indicators, and we'll go through all those in just a second. The idea is that these are ambient information radiators, right? They bring information from all over the place to bring it back to you in the context of where you're working. This is where you are. You're in the editor. You're right here. This is where coders work, right? In fact, I sometimes like to show my teams that, in fact, when I code, my system looks like this. So I have no tool windows open. I have nothing up on the screen at all except code. And I typically have 2 of them up side by side. Sometimes it's a test and some product code. Sometimes it's 2 different pieces of code, maybe the one I'm referencing and the one I'm authoring against. So this is where I'm working. This is where I'm looking right now, and I need information while I'm working. So let's put this guy back over there. Move him over there and zoom it back in so you guys can see. So this method is kind of one of the core methods of this system. This application, as I said, it reaches out to the geological survey and pulls down data for me, pulls it down as an XML stream, rips it all apart, and splashes it back into the view model where it presents inside of the mapping system. Now, if I was going to go wanting to start working on this method, there's a lot of things that would be very interesting for me to know. If I'm going to make changes to a method, one of the things I care about very quickly is how many other places in the code call into here. Because a change here when I have a lot of incoming calls is potentially dangerous. I have to be very careful about it. It's not that it's always dangerous, but it's an indication, it's an indicator, so something I might be interested in knowing. Of course, you've previously been able to, select the method and right-click and find somewhere in this giant menu, find all references, right? And then you have this list, and you start looking around, and pretty soon I'm somewhere else in the code, and I don't even remember what I'm looking for anymore, or maybe I've opened Solution Explorer and gone somewhere completely different. And I don't even hardly remember what I was doing anymore, because the context was lost as I did this. Or I may have gone to TFS and opened a work item. A lot of things I might have done, and I lost the context for what this was for, because it's detached. But if instead we take that information and put it right here, what this is telling me is that this method has 7 references. There are 7 other places in my solution that make calls here. Now, you might be interested in knowing which 7. That's 7. So I can just click on the indicator and get that second order bit of information. I can mouse over them and see the code that's on the other side of the call. Right? And you'll notice this is all really quick. I'm not faking this here, so you hear me there. Click, mouse over. Okay? So the point of this is that we're maintaining the models of this stuff, but we're also very, very sensitive to the performance impact of this kind of thing. And we've done a huge amount of work to make sure that this is not slowing down Visual Studio. So this allows me now to browse through these, and I haven't had to leave. I haven't had to go elsewhere. I can see what the code looks like. I can see what the reference is. And in fact, since these preview builds have been created, we're continuing to evolve these indicator panels, these pop-ups, to give you richer information and richer browsing models, different ways of thinking about how to see that, because right now this is just kind of a flat list. There's other things we might be able to do to make that even easier to understand and comprehend. And of course, just like you expect, double-click goes right where you think it would go. So the references one is easy, and you can see that one says 7 references, and if we were to compare it with find all references, which is one of the first things people do here, find all references has 8. And we have 7. So I kind of have to explain why. Find all references is context-free, right? It's in a floating tool window. And the way they address that context-free is that the first item in list is the one you started with. Well, we're not context-free, so we don't need that one. So we're always -1. So when you start playing with this and you start saying, oh, those numbers are different, I don't know if I trust them. No, it's the same stuff. It's the same stuff. We just hid the one that was kind of wasteful. Right, and it's this first one right here on the list that is kind of itself. All right? So let's see, we'll go back to where we were. There we go. So the references information is interesting, but there's other stuff we have. I mean, that one's just kind of one of those ones where you think of the structural model of .NET code and the various things that we can get out of the models that are in the language system. Right, that's all we're doing really is bringing that back to you and putting it in context right here. But there's other systems that might be also interesting to start to bring from places where maybe they're not very accessible to you. And the next one that you can see on the screen right here is a test passing indicator. You can see it's the same icon that we have in the Test Explorer over here. Same icon, so that you recognize it as being that. And what this is telling me, it says there's a failure mark, and then it says 4 of 5 passing. Now, this isn't a test method. This is a method in my product. So what it's really telling me is that there are 5 tests that call here. And 4 of them are passing, and 1 of them is failing. So I didn't have to go to my test code to find that. I found it right from here. So I might say, well, which tests, and in particular, which one's failing? So again, I can click, and there it is. And of course, it's set up so that it looks and feels kind of like the Test Explorer, so we start to get that integrated experience. And I can also select these tests and run them. I think I'm in the debugger. So we go and so here's our Test Explorer over here, all is well. All right, so I'm going to select that failing test and run just it, right from here. Didn't even have to open the Test Explorer window. So I actually find that now that I have these indicators, I run with that window collapsed a lot of the time. So I can run just that test. You can see they gray out just like they do in the Test Explorer. Only that one ran. The rest of them are now kind of grayed out, which means the data is stale. The last time we saw it run, it passed, but we're not sure anymore. And of course, if I want to look at that test, I can double-click and go straight to the test. Now, the test also has an indicator on it that's a little bit different. That other one, the one that was on my system code, we call tested by, right? So it's in other words, it's show me any tests that make direct calls into here. And let me be very clear about that. I mean, they are literally direct calls. So if it's like a multi-chained effect where a test calls A and then A calls B and then B calls C, we won't show that test on C. Okay, we're kind of targeting intentionally here at this point that direct unit testing scenario, these are the key tests, the key ones for this method. And we are looking at, in the future, how we might continue to extend that out and try to figure out how far down that graph to go, but that can lead to very long paths, and we want to, again, be very sensitive to performance implications. So for most code where we're writing unit tests, developer-oriented tests, it's actually quite good. It gives me the key set of tests that call here. But now I'm in the test itself, and we know this test failed. Why did it fail? Well, again, I'm going to come up here and click on the indicator, and I'm going to see the exact same detail information that we have in the Test Explorer. We can see the failing message, this shouldly chucked a wobbly, which is some strange exception library that I'm using. And it was expecting one particular time but not another, and I can see the stack trace here. I can expand and collapse the stack trace just like I can in the Test Explorer. And I can click on the links in the stack trace and navigate through to code as well. So we can see here that this is the failing line. It was expecting a 1 second time interval and clearly got something different. So now we got to figure out what happened here. So I'm going to use the back button. You guys all know about the back button, right? A lot of people, I'm surprised, don't realize that Visual Studio has a back button like a browser. So you just hit this back button a couple times, you go right back to where you were. It's Control- on your keyboard. All right, so I need to figure out what it was that was making this thing fail. And we saw that it was a timing problem. And we can see from looking at the test that, in fact, it's looking for a 1 second interval. We're trying to figure out what the heck happened here. Well, sometimes when you're researching a bug, especially a bug that comes in kind of surprisingly, like you weren't really expecting it, what you'll do is start to research the history of the code. Try to figure out who was messing around in here. Who was changing stuff on us? Well, what these next two indicators are telling me is information that we're mining out of and extracting out of Team Foundation Server. So we know that Julia was the last person to make a change to this code. And we also know that there are 3 commits in the check-in history that modify this method. And we can now go and take a look at those. So let's start with the changes one first. There's 3 changes that came in here. And we can see here's a bug fix that Julia thinks she did. So let's go and take a look at that. I'm going to double-click on this bug fix change set. Now, we did a couple things for you here. We reached out to TFS and pulled down that change set definition and opened it in Team Explorer on the side. Because I have all my tool windows closed, you're not seeing that over there. But there it is. So here's the change set details. I can see the notes. I can see all of the files that were included in the change set. But we went ahead and also opened this file and scrolled the method you were looking at into view. Again, trying to allow you to persist that context, that situational awareness of what bit of code you were thinking about, what problem you were trying to solve, and we're trying to figure out now what did she do. Well, it doesn't look like this count thing was related. So we'll come back over here and check the second one. Ooh, hold on, she's playing with the timer here. That looks like it might do it. Let's see, the 4-parameter version of time span, by putting the 1 in slot 3, it's minutes. So she accidentally changed this timer from a 1 second timer to a 1 minute timer. And our unit test, which was designed to catch that kind of thing, caught it. Unfortunately, it seems Julia didn't run the tests. But I'll show you how we can make it so Julia should have remembered to do that. So we know that that was the problem. If we scroll down and look at the code we have, yep, there it is right there. Well, maybe we're not sure why Julia did this. Maybe she actually had a reason and the test needs to change. So we can come back up to the indicator here, and we click here again and we say, okay, this check-in number 37 to Julia, I'm very interested in talking to her. Now, if you notice, it's kind of subtle, but are you noticing that this is becoming a hyperlink? There's a bit of underlining there. So if I click on that, it's attempting to open email, which is not running on this Windows 8 machine. Basically, what it's going to do is it's going to, if I right-click, you can see the same thing. We can do send an email to Julia. Okay? We're opening a mail to link. We've already looked her up in the Active Directory and in TFS to try to figure out what her email address is, pulled that information down, and we'll populate an email message that's already sent to her. We'll fill in the change set details and everything else. Now, other things that we're looking at for the future include presence indication, like into link or something like that. So you can maybe have a more dynamic conversation than email. But in the preview bits, you should be able to start using email almost immediately. Okay? So we decide we don't like that change. We need to fix it. Excuse me. All right, we'll come down here into the code. And we will make the change back to the way we thought it was supposed to be. And I'm going to use the same trick I did before. I'm going to run all of the tests that pass through here. All right, so this is going to automatically build my code, bring up the tests and start running them. And we can actually watch this panel if we want, try to see the status as it goes by and as the test result data comes back. Hey, look at that, they all pass. Now again, the thing about these information radiators that we have here is to note that they're intentionally subtle. We use that gray type. We make them smaller than the regular text. We try to get them out of your way when they don't have anything really important to tell you. So when we had a failing test, there was a big ugly red icon. It said, hey, look at me. But now we have passing tests, and it went back to that subtle gray. There's no reason for us to splash a big green icon on you. Passing tests we should ignore. It's the failing ones that we're upset about. So we now are happy there. But, it really would have been nice if Julia had just run the tests all the time, maybe every time she did a build. And so this is another one of those little productivity things that I want to make sure everybody knows about. Julia should have come over here and toggled this button in her Test Explorer. And what this says is run tests after build. This allows me to automatically keep my tests running as if they were a part of my compilation step. Because I don't know about you, but when I'm coding, I generally just hit, Control-Shift-B. I had to look down to see what it was. You just hit that. You type and then you hit that. You type and then you hit that. And you just keep hitting the build instruction, right? I'll do that instead of saving, because it saves anyway. And just to show you that works, let me put the error back here. Okay? And I'm not going to hit the indicator. I'm just going to hit build. So you can see me do it. I'll just do this. Build. And I'm hands off the keyboard. So now it's going to build the system, and then the test runner is going to automatically pick up the tests and start running them. And when that information comes back from the test runner, the indicator in the editor turned red. So right here, while I'm working, while I'm doing coding and build, little test, little code, little test, little code, writing code and building, I get those indicators back right like that. Nice and quick, and here where I need it, because this is the context where I'm working. One more time, we'll go back to green, because I do not like having red in my test runner. Okay, so now we've seen those five indicators that we've brought in through this code information indicators panel that sits in our code like this. So quick, we've got the changes one, we've got the one that talks about authors, and if we had multiple authors on this, it would actually show plus. So in this virtual machine, I'm logged in as Julia, and I'm the only one who's ever checked in this code. So what you're going to see is just myself all the time. But in a situation where maybe myself and Josh and Aaron have all done code check-ins, the last person's name shows up. Because let's be honest, they're the one who most likely made the bug, right? Right? So we would see, Julia plus 2. There's 2 other people. Right? And we've been using this on our own code bases with extremely long, old histories. And it works great because we've actually now introduced some capabilities, some new service capabilities inside of TFS that back this up to enable all that. So we can pull that information out very quickly. All right. One of the things that a lot of people start to ask me about as they see these indicators is kind of what the experience is of having them in the editor. Like they think, oh, that's kind of weird, right? They're right there, you know? I mean, aren't they going to be in my way, in my face? So I wanted to show you kind of how it feels to work with these things while I'm actually typing in the editor, so you can get a sense of that. So you can see I'm giving an attribute here because I'm going to start writing a new test method. And so far, nothing, because in fact, the logic we have in there that is trying to make a determination of whether there's something interesting here, it hasn't found anything interesting yet. All right, so then we'll go public void foo test. And now the indicator panel appeared. As soon as it identified that we really did have some code here, it appeared. Right? And if I go and back that out, he'll make it go away as soon as he realizes we don't have a method here anymore. And you see it squeezed it back together. That space isn't really there either. That's kind of the thing that sometimes confuses a little bit of people. Notice my cursor's here on public. If I go up one, right? Just to kind of prove the point, I'll turn on line numbers. There we go. All languages, line numbers, go. So you can see we've introduced just a little gap. It's not a very big one. And you can control that font, so if you want it to be even smaller, that's not a problem. Or maybe you decide you don't want to use one of these indicators. You're not interested in having one for some reason. Well, you can actually control that as well. So if we go up here into Tools Options, and in the Editor section, you can see we have Code Information Indicators here. We go here, and we can turn on and off different indicators. Control what we want to see or not. Okay? And we've also had a few people come to us and say, well, I think it's weird that it's after the attribute. Sometimes the TDD folks say, why is this after the attribute like this? Well, if you've done a lot of attribute-driven code, you may have noticed that, you know, it happens that you sometimes end up with a lot of attributes sometimes on code. If you're doing data-driven tests or other things, you may end up with this. And let me tell you, if that indicator was up here, it would not be very contextual when I'm down here thinking. So that's why we did it. And we did that after a lot of user studies. We brought people in who were working on real production code that they had, where they were very attribute-driven. They might have been doing package code for Visual Studio. That was one of the groups of people we worked with. Also people who were using some of the test frameworks that support inline data, like NUnit and XUnit and MBUnit, where they had these big, long attribute lists. They clearly gave us that feedback to get that out of there and push it down. Okay, so I've shown you the test runner, the automatic test runner. That's actually been in since Visual Studio 2012. And this code information indicator that we have right here above that's giving you all this great hints and tweaks. Okay, we have a quick peek to where I am. Excellent. Okay. So a little review here of kind of what we have in these code information indicators then. So that references indicator gives you quick access through and into the call history of that method, the people who make calls into that method, and allows you to browse that in context and clearly right in the code. We have two that are helping you out with testing status. And we have two that are pulling information from Team Foundation server. We are currently working with a lot of different groups inside of Visual Studio to try to think about all of the other places that we might be able to pull information from and bring that to you in the editor. But in the preview builds that you guys are going to get in a couple weeks, you're going to have these 5 there. Final thing I wanted to do is, let me hop back over to code here. All right. So we were talking about the context switching problem, right? So we're thinking about the context. We've got this context problem of when we're in the editor thinking about the code and the structure of the code and where we get our information from. But when you actually have to do a hard switch, when the boss comes in and starts giving you grief and says, hey, help me out, you got to go fix this bug here right now, you need to be able to kind of persist and save your information. keep what you've got going on. So if I come back over to here and kind of get ourselves set up to where we were, right, I have a breakpoint here. Let's get ourselves back through. I'll build up my call map. Okay, good. So I'm here and I'm working my way through this problem, trying to figure out what it is, and that's when the boss comes in. Goes, hey, stop what you're doing. We got to go fix this other thing. Right? I've got my little notes, I've got my little flag bits of information, I've got comments on these things. So what am I going to do? Well, it turns out that if we go and take a look in Team Explorer, and I have to stop debugging here, but I still keep my map. We'll go take a look in Team Explorer. One of the things I can do through the My Work section of Team Explorer is I can suspend my work. And what suspend is going to do is it's going to package up all of my changes to the code and a whole bunch of various environmental settings in the IDE for me. So I'm going to hit suspend and just let you watch what happens. It's telling me I've got 2 edits. Go. Yes, please save that map. All right. So it cleaned me back to baseline. And in fact, if we were to go look in the pending changes window, you'll see I do not have any more pending changes. Okay? This is not one of the changes we were just working on. This is me screwing around beforehand. So I don't have any pending changes, which now allows me to go and work on the bug. So I may go back into Visual Studio or back into Solution Explorer and start working my way through a different piece of the problem, setting different breakpoints, right, trying to figure out what's going on. And then maybe, I fixed the bug. So I'll build here, make sure everything's good. Okay, boss, your bug is fixed. All right, so we've checked it in. Now I want to go back to where I was. Well, if I go back into the My Work section of Visual Studio, you'll see I have a suspended section here. And this is the suspend that I was doing. I'm going to hit resume. We're going to pull all of that back, reopen it all back up, reestablish all your breakpoints, put all your windows back to where they were, get you right back to the exact same scroll positions in the files and everything. And in fact, my pending changes window now has all of my changes back in it. So it allows me to take that situation and not just from a version control perspective stash it away, but the environment of the IDE as well. I get right back to where I was. I continue what I was doing, F5, straight back into my breakpoints, and continue what I was doing. So this kind of a context switching model now. So we've got the code sense indicators giving me information from TFS, from the test system, from the code model. We've now got the ability to take this IDE experience with the setup of your windows, your breakpoints, your open documents, scrolling positions and everything. Save that and bring it back when you want to transfer between 2 different states. If you activate a work item, which is another thing we can do. So if I'm here in my work and if I have a task assigned to me like this one, I can drag it up here and activate it. And now what it'll do is it'll start to associate the work I'm doing with that check-in. So an interesting thing, right? There's a lot of power to be had when people will do the extra effort of associating a check-in with a work item they're doing. They're fixing a bug, they're working on a user story. But it's kind of annoying to do. You have to remember to do it. What was the work item ID? Oh, I forgot. And you have to check the little thing and find it. Well, you don't have to if you've done this. So I've activated this work item. I have now some pending changes. We can go and check the pending changes list and confirm. All right, so I have pending changes. We can see the active work item shows up here as well. Now, the next thing that I'm going to want to do, I'm in a team environment, and we like to use code reviews to evaluate code before we put it in. Maybe I want to get this checked by one of my colleagues. So I can go here and say request a review. Now this little warning is just saying I don't have an email server, but we already saw that before, so I'll just tell it to go away. So we can go ahead and hit this, and we're going to find other people on our team. So I'll say, Brian, I want you to do this review for me. And I am also going to add myself, just to make it so I don't have to log out of the machine on you guys. But note a few other things here. It already knows what the work item is that I'm working on, and is pre-filled in the description. Code review for bug 71 with the description filled in. It's associated the work item so the reviewer has a chance to navigate and understand what it was you thought you were working on. It's attaching all of the pending changes, and I can add some other notes as well. Hey, take a look at this. And submit it. Yes? Apparently, Brian Keller, who built this VM, does not actually have permission to this VM. Okay, so we're here in this My Work section again, and what I want to point out now is that now we actually have my new code review, this bug 71, showing up right here. This is the code review that I just submitted. And so on the receiving end, what Brian or any of the other reviewers can do is open this up, and they can see who the other reviewers are, follow along with what the related work items are, and the related work items in that tooltip are letting me see that information. So again, I don't have to lose my context in order to understand what they were working on. There can be comments already in here, as we see, and I can add another one. I'm looking at this. Now you might wonder, why would I enter a comment like I'm looking at this? Well, all of this information is actually being stored in Team Foundation Server. So that means when the other people on the review chain open this review, they're going to be seeing live context of what I'm doing. So they'll see that I'm reviewing it, or I'm looking at this file, but they can look at this other file. Or maybe I've already put a comment on the thing that they're about to say is bad. So while I'm reviewing through the code here, I can open these up. And when I open one of these files, what it's doing is giving me that same change set, or that same diff view that we had when we were looking at it from the code information indicator, and allows me to go and take a look at what's happening. But maybe I'm not sure I want them to do that, so I can add a comment. Not sure you want to do this. So now we're basically building this code review collaboratively, all the members of the team potentially having access to it. All the information's on TFS. Now when I say I'm done, okay, I think I'm finished here doing this review. Let's send my comments back. All right, so now I'm on the receiving end of the code review. I've got it back from the reviewer. And I want to go and take a look at the things they're saying. And as I'm taking care of them, they might be saying, no, you probably want to do this, or don't forget to do that over there. I can check them off on the list. Okay, working my way down, taking care of all these things, and now I feel good about it. Excellent. And since I've decided it's good, it's been out for code review, my team feels pretty good about what's going on, I now can go over to pending changes. And again, notice that when I go to commit this, it's also now going to associate, like you can see here, associate my check-in with the appropriate work item. This should fix the timing bug. All right, so now we were leveraging that capability of the My Work pane in Team Explorer to do that context switching, to go in and out of one particular activity. We can actually have lots of different ones suspended at a time. But of course, that just starts to use up more slots, right, in your brain. You've got to go back and forth between these things. But we're going to bring back the context of where you were, the debugger state, the open windows, scrolling positions, all that good stuff. You can go back and forth between them. We can use code reviews to send that out. Of course, the code reviewer also can pull your code down as a shelf set and then leverage all the power of the code maps and the code information indicators to start figuring out what's happening. So they can explore through your code in the exact same way you were doing when you were putting it all together. Okay? All right. Let's put that away and go back over here. Okay. So hopefully what you guys are seeing here now is this. We're making a very intentional and conscious effort to try to bring contextual awareness and rich information at your fingertips to you in the editor where you can use it. As developers, that's where we spend our days. We spend our time in the editor working on code. We're writing code, we're running tests, we're exploring, we're navigating. We've got visual maps to help us see what's going on. We've got context management, so we can go in and out of various state transitions, maybe work on this, work on that. We can use code reviews, which carry all of that information with them. Using these tools allows us to get that richness of the mappings between change sets and work items, so that later when somebody else comes along and is using those same code information indicators to look at something in the future, they actually can now travel back through and see those work items as well. So they know what you were working on. Trying to keep that contextual flow of the work items, the bugs, the code, the information, all right there where you can use it, where it makes the most sense to have it. Okay, so I'm going to open us up to questions here in a minute. I wanted to make sure to leave us a little bit of time here at the end, but I also want to make sure that we have a few minutes to go through a couple of other things. We've got some other talks here that some of them have already happened, but some of them are still coming, and I want to make sure you know about them because there's some important stuff coming up here. The one on the left-hand side, Brian Keller, Modern Application Lifecycle Management, has already happened, but if you missed it, you should go back and watch the recording of it. Agile Software Development with Visual Studio ALM. Aaron Bjork and I did that one this morning. We basically did a lessons learned talk of 5 years of us adopting Agile inside of the Visual Studio product team. You're in the green one right now. There's one missing off of this chart, which will be tomorrow. Joshua Weber and I will be doing a session on how to deal with legacy code bases from a testing perspective. How to leverage and take over and basically re-empower yourself against legacy code by using the testing capabilities that we have, including the information indicators and some other stuff like Visual Studio Fakes. And then tomorrow, Aaron is going to be going through a very deep dive into Team Foundation server planning and take you through all of the new portfolio management capabilities that are coming in 2012. So now, if anybody has questions for me, I'd like you to use these mics, please, and just kind of put your hand up so I can find you, and I'll happily call on folks for questions. All right, I see one right here. Can we get a mic here? This is number 4.
Yes.
3.
Hey, there you go. Where are your suspended work contacts? Where are they stored? I mean, can you access them from another location if you're signed in?
All right, so let me make sure that I'm playing back your question correctly. If you do a suspended work, can you get that back on another machine? Right now you cannot, but that is something we're actually very interested in or exploring. One of the other variations of that scenario is actually that I might suspend it and send it to you. Now, it turns out that there's things inside of Visual Studio that maintain some of that information that don't allow us to package it up yet, and we're working on getting those changed so that we can. Thank you. But the rest of it is all stored in TFS, so we're close. We're almost there. See another question? Yep, right there.
The code information, does it work with any other source control like SVN, or it has to be TFS?
So right now, the code information indicators are only working against Team Foundation server on-premise, with Team Foundation version control. As with the other stuff you've been hearing us talking about Team Foundation with Git, we're currently exploring that and plan to deliver that in the future. Thanks. I can't tell if people are standing at microphones. Over there, yes? Number 1.
Code information, is that useful on ASPX or scripting languages?
So in an ASPX file itself, it does not work right now. I've been having meetings with the ASP.NET team to talk about what we might be able to do there. It turns out that, in fact, there aren't actually a lot of functions typically in an ASPX file, right? And we're typically putting these things on classes and functions and properties. But you'll make a lot of calls. What we're trying to work out now is how best to make sure to collect that information from not just ASPX, but also CSHTML and some of the others. And then also the ASP.NET team has been expressing interest in taking this information indicator panel concept into other file types that they have for, honestly, completely different reasons than we would use it in an object-oriented language. But we're still trying to work that out with them.
Including JavaScript?
So again, we're working on that. And understand that to have this, we have to have certain capabilities provided about the language. We have to be able to have a very rich parsing object model for the language. We have to be able to do a lot of things. And so what we're doing right now is talking to all of the different language teams to try to figure out how and when we can bring those experiences. Thank you. I see a question at the back here. I don't know what the number is. Right there at the back? Yep, you're on.
Okay, I'm just going to ask about the reference counts that you have in the code information panel. Mm-hmm. does that count references going through an interface, or is just direct references?
So basically what it's showing is the same information that we get from the find all references system, okay? So what that really means is that there's symbolic references. So when you have an implementation of an interface, the actual symbolic name of that method is interface.methodName. And so we're going to find everybody who talks to interface.methodName. Now it also can be, of course, if it's not explicitly implemented, it also can be a public method on the type. So we'll get those as well, just like find all references does. Now, that means if somebody else is making a call on ifoo.bar, and that's what this is, it'll show up. Now, of course, since it's interface and polymorphism is in play here, there's actually no guarantee that that call ever happens because we're not sure exactly what concrete type gets implemented. We're not doing this with a profiler or anything that talks about concrete code paths. Right? We're doing this with static analysis of the code system and how it's put together. Okay? Trying to see, is there a mic? Somebody raised their hand. Yes, right here. Number 3. Number 3, please. Go ahead.
You said the indicators won't slow down Visual Studio, but will they slow down the server overall? Like, is it asynchronous calls that are eating up
Right. So the feature that the capability that we added to TFS is actually very light in the way it handles it. It runs using background jobs. It runs very subtly. And in fact, it builds up its information slowly over time. What's interesting is that when you first bring this up against a code base that already has an existing history, in the indicators, you won't see very much yet. Because it doesn't just immediately start a job that just kind of bogs your server down and tries to process the whole world. Now, what it does is it starts kind of, we talk about going in 2 different directions, right? So it starts kind of slowly working its way backwards through time, and it just works its way along without trying to be over too invasive. And then it processes new change sets as they arrive, so that's the moving forward point, right? And it starts to build those both out. So when you first put it on against an existing code base, you might only see 1 or 2 change sets in your history because that's as far back as it's gotten yet. So we're trying very hard, we're working very, very hard and working with the TFS team and with the Visual Studio Shell team to try to make sure that none of these things degrade your experience. Still 3, please. Still 3. Thank you.
We have multiple developers working on the same server. Would you be concerned with all of the developers having that turned on the same server? Like maybe we should say only 1 or 2 people should have it turned on?
No, so the indicator being turned on in your IDE has almost no impact on the server. Right? So the processing engine on the server is processing change sets as they get checked in. Excuse me. And the actual act of processing a single change set is not a very expensive operation, right? Pick up that change set, take it apart, try to figure out what methods get called, store that in the database. And we do the same kind of thing going backwards in time. When the indicator makes a request for information about a method, it's this very, very lightweight service hit. 1 hit back information. And then we cache that, and we do it on kind of a controlled manner to try to avoid aggressively pinging the server with too many requests. Now, if you do a check-in, well then in the client, we know that you just changed the state of the server, so we will refresh. And not in the build that you guys are going to have access to, but in a later one, you actually can forcibly manually refresh if it hasn't quite caught up with you where you want it to be yet. But the act of turning on CodeSense inside of the IDE, the number of people involved there should have little to no bearing at all on the performance of your TFS server. To give you a sense of it, we run a kind of a dog fooding instance of Team Foundation server inside of our teams. And I think we have about 250, 300 people running against this dog food instance. And it's just a regular machine. It's not like we bought a great big farm for it or anything. And all of those people running it with all of the dev source code on it. And there have been, since we turned it on, there have been 0 bugs filed against us for people feeling like we slowed them down.
Wow.
So we're quite happy about that.
Okay, thank you.
You're welcome. All right, I see one at the back over here. That's that one.
You did the code review in the Team Explorer.
Yes.
I was wondering, would the code reviewer have the same features in Team Web Access?
Not right now. It is something that we're investigating. There are some new lightweight code review things coming. You should probably go and check out, I think it would have been Martin's talk a couple of hours ago. He may have talked about some of that. And what we're trying to figure out the right way to do is to bring these 2 things together. bring these two experiences together, because there's always things that you can do in an IDE that you can't do up there, and there's things that are very fast and light and easy to do up there, like just a quick read through and throw a comment on. So what right now we're working on is trying to resolve those issues and try to make sure that we bring in an experience that is great on both sides. In the preview bits that you're going to see right now, you are going to see a difference between them, but it is something we're looking at addressing.
Thank you.
You're welcome. Up here in the front, please, and then I'll get you next.
So you mentioned that it's available only on on-premise. Is it going to be moved to the hosted service as well?
Yes, it will. It just has not yet. Right here, please.
So if we are using the preview version of Visual Studio, will we have to have a preview version of TFS to utilize this as well?
So of those 5 indicators that I said, only the 2 TFS indicators expect you to have the updated TFS version. So if you use the preview bit version of Visual Studio with your existing TFS instance, you will still get the other 3 indicators, the 2 testing indicators and the references one. If you want to experience the 2 TFS indicators, the changes and authors ones, yes, they will need you to be running a new TFS instance to basically get the new capabilities inside of the TFS server. Okay? Oh, there's another question on the same mic.
Yeah, this one is really about the indicators. So what are possible future indicators that we might be able to expect? And as a developer, my first thought was, I want to make my own indicators. So
Sure.
Is there any way to customize that? But obviously, with the concern of performance, all of that goes in. So
let me take that as 2 different questions. One, what kinds of things can I imagine for the future? And of course, I'm going to have to be very speculative there. And then the second one was about the extensibility. So there's actually a lot of things that we've been hearing from both internal dog fooders and MVPs and others who've had some early views of this. We've had people talking to us about interesting measures around code health being something that would be interesting to see there. And there's a number of ways you can tackle that. We can show metrics, which is interesting, I think, but at the same time, it's almost very academic, right? If I tell you the cyclomatic complexity is 14, you have to go look it up on Wikipedia to figure out what that means. I've been wondering instead whether I can perhaps combine a set of metrics and give you a more interesting measure of health, like B-. I don't know if that's the right way to do it, but you can see the kind of idea I'm thinking of there. And then we can start to imagine maybe if we took that same information and also did it on the server, we could maybe get historicals. We start to track how has this method's health changed over time. Things like that are the kinds of things we can imagine. Anytime we're basically looking at another system, either inside of Visual Studio or maybe outside of Visual Studio, like in TFS, or maybe outside of Visual Studio, like in the cloud somewhere, and the data that it's collecting is relevant to the code that you're working on, we immediately start to wonder if that contextual data at your fingertips, that information radiator, could play a part. So we've been looking at a lot of them. But that's probably the first one that comes to mind. Of course, the references one is talking about calls in. We've had people ask us for calls out, right? Particularly if they're in the presence of a long method. Right? Of course, nobody likes to admit that they have methods that are hundreds of lines long, but we all know they're really out there. And when you find one of those, you can't just take the argument of, well, there it is, it's in the code. No, things can be very convoluted, and knowing where this thing calls is interesting. We've also thought about taking that same concept and integrating it into the code map. So you see that it's got 37 calls out. You look and you say click, and the code map appears. So we're looking at a lot of things like that to try to, again, find the right set of experiences that bring the information you need to be most informed and make those hard decisions, situationally aware. Now, your second question about writing your own. In the Visual Studio 2013 wave, there is not an open extensibility model for this. But you're not the first person to ask us about it, and so it's something that we're very much looking at for the future after that. We have to make sure that anytime we take an API, especially one in the IDE, and we open it up for public extensibility, we have to be very sensitive to how third-party extensibility is going to impact your performance. Because when you go and install a third-party component off of the code gallery or off of some other site, and Visual Studio crashes to its knees, I'm the one who gets the call, right? not the guy who wrote the thing on Code Gallery. And you guys start to say Visual Studio is slow and piggy. And we've worked really hard in the last few releases to try to eliminate any of that opinion, right? We worked really hard to try to make this thing faster than we can imagine, and we're still trying to make it faster every day. Trust me, we take our performance numbers very seriously. And so that's the concern we have there, and also making sure that the API that we publicly expose is kind of complete enough to allow people to do all the scenarios they might want to do. If people started wanting to put indicators in that are reaching out to their own services, we need to be very thoughtful about what the API looks like that from an extensibility perspective. So I think we will, but it's not yet publicly extensible. Okay? Are you back at the mic back there?
Yep.
All right.
Can the saved workspaces or shelf sets be combined with the current workspace, or do you just have to crush them still?
You can. You can basically unshelve it, because when we do a suspend, we do create a shelf set.
Okay.
And so if you then start to proceed down producing some pending changes, as with any other shelf set, you can unfold it back into your current space. And you can do it right from that suspend screen. I just didn't show that part.
Okay. Cool.
But yes. In fact, that's a very common scenario when you do get sent off to fix a bug. Because effectively, you want those pending changes to come in with the bug, right? You don't want to have to go double time here.
Yeah.
Okay, great.
Thank you.
No other questions, and there's just a couple minutes. Oh, there is one. Sorry, at the back.
Hi. So with respect to the code indicators, is there any intent to eventually support subversion?
So to eventually support subversion, well, as I said, right now we are in TFS with the Team Foundation version control. We do have plans to bring it forward for Team Foundation Git and for the cloud, as the question over here was. As for other version control systems, we don't have any direct plans for how to address that problem space. I'm not saying no. Well, I'm saying yes, no, we don't have anything on the plan right now. But that's not to say we won't. It'd be an interesting conversation I'd like to have maybe if you can meet me at the booth at some point and we can talk through the scenarios. Because, of course, we have to balance how far down that road do we go. Right? And how many should we support and what extension models exist. Because maybe that's how we might be able to choose to support it is through extension. Because, of course, once we have the extensibility of the indicators, we could potentially allow a third party to create such a thing like that. Okay?
Thank you.
Thank you. Oh, another one at the back.
Just a really quick one.
Okay.
Can the code review transcript be included in the check-in, as part of the information that gets into the server?
So it is associated.
Okay.
Excuse me. The relationships are all maintained. So the change set is associated to the work item.
Right.
And the code review is associated with that work item. So everything is all glued together, and you can find it all through the work item. The work item tends to become like the parent where everybody meets. So the code review will be attached there, the change reviews will be attached there, and all of that's available to you so you can go back to it. Okay? Thanks. All right, one more over here. We have still a minute and a half on the clock, so we're okay.
Yeah, on the code indicators, if I'm not using Team Foundation Server, do I lose all of them or just the ones associated with changes?
You just lose those two. Great. In fact, since that's the second time that's come up, let's go back here. You just lose the orange ones. Okay? The green ones and the blue one are still there. Right, and basically it's just because the pieces inside of Team Foundation Server that are aggregating that data for us are not running on your older version. Okay? All right, and up here? Number 2.
There you go. The code indicators, the test, can I run it under NUnit?
Yeah, so it uses the exact same test running engine that we introduced in 2012, which has that pluggability framework to allow you to run all of the different kinds of test frameworks. It's the same engine, it's the same backing data store. All we're doing is providing an integration. So if I had written those tests in XUnit or NUnit and had the NUnit adapter installed, everything would have been just fine. You would have got the same indicators in the IDE.
Awesome.
All right. All right, I'm actually out of time. The clock has gone red, so I'm going to end it. But again, I will be hanging out over here if you have any questions for me, and hopefully I'll see you at the next session. Come on up.